All right, so here's your printed circuit board design, and what I can see, you already inserted another linked component into this. So when you work with imported geometry, it usually imports with the timeline turned off, and you need to enable the timeline if you want to record your design history. But in this case also, you have this one body at the same structural level with a component, and generally I don't recommend that. So we don't need this anyway, so I'm going to delete it, and then I'm going to turn on the timeline. So now we have the geometry that we need to work with, and this yellow piece here is a flex board of the Flex PCB that you want to bend. And that can be done. The workflow that I'm going to use is I'm going to convert this into a sheet metal body. So the first thing that we need to do, we need to split this off. So I could go into just use the split body function. This is my body, and that selects the entire geometry, and this is my splitting surface. But what it's going to do, it's also going to split the ends off here. So in this case, I'm not going to do that. You could recombine these ends back to the original body here with a combine feature, but I'm going to also use another command here. I'm going to create an offset of this one surface by 0 millimeters, which basically copies that surface. And we can see that this surface has holes in it. So I can't use it as is for splitting. So I'm going to use the untrim command, and when I select it, we can see that it already hides or eliminates these holes. And I have set it to internal edges, so that's what I'm looking for. I just want the internal edges to be removed. I want the exterior size to be exactly the same as it was before. And if I unhide that, now I can use that surface to split off my Flex PCB. And don't select extend splitting tools, because then you end up with the same thing that you split off these little ends here. It might in fact be easier to recombine those, as I showed initially. But anyway, so now we have our Flex PCB. So there's still too much stuff on this Flex PCB, the logos and text up here, all these contacts, and the stuff here on the bottom. So what I'm going to do, I'm going to create a folder, and we'll see in a moment why. I just keep the default name of group 1. And I'm going to modify split body. I select the entire body, and then I'm going to select the top surface and extend splitting body, and that is going to create a lot of split of bodies here. So I'm going to select the first one, scroll all the way down, shift select the one at the bottom, and that selects all the ones in between, and then I'm just going to drag those into that group. All right, so I'll hide that group, so they're all gone, and I'm going to split body again and use the bottom surface, and I have 2 more bodies that I'm going to select and drag into this group. So now I have 92 bodies in there. So that keeps our browser nice and clean. And now I'm going to convert this into a sheet metal object. So I go into the sheet metal tab, and what Fusion 360 does when you convert something with the convert to sheet metal, it picks a sheet metal rule that is close enough to the actual thickness of the material. So before I do that, I'm going to create a custom sheet metal rule just for this printed circuit board. And it might become clear why. So in order to do that, I select one of the rules that are there, and I select this icon to create a new one. And I'm going to rename that into Flex PCB, and that is 0.1 millimeter thick, and we leave it at that. So the thickness again is 0.1, and I don't want a K factor. So the K factor is a material specific setting. It's different for steel than it is for aluminum, but in this case we want it to be 0. So later on, when we use a bend line, we'll have exactly the bend radius that we specify. Bend conditions, thickness. Well, for the moment, I'm just going to give that 1 millimeter, and I save that sheet metal rule. Let's say close. And now I can go to create, convert to sheet metal, select it, and it picks it here. Thickness detected 0.1 millimeter, so that fits our sheet metal rule that we just created. And we click OK. So now we can see in the browser we have a sheet metal body. So now what I'm going to do is I'm going to use a bend line. So in order to use this bend function, I need to have a line that I bend around. So I create a sketch on the bottom face, and I project 2 edges into that. And then I'm going to convert those projected edges into construction lines. And I create a line in between. And the only reason why I'm converting something is so I can later use an actual dimension to fully dimension and constrain that line. So I say, okay, there's my sketch line. And now I'm going to create a bend. So what Fusion asks me to do is to select the stationary side. So this I want stationary. Now I need to select the bend line, and it bends it around 90 degrees. So unfortunately, what I would really want, of course, is I want to bend this 180 degrees. But Fusion complains because that would usually not be a good thing with real sheet metal. So for our purposes, Fusion tries to be smarter than us. So we give that 179.99 degrees. And say OK. And the bend radius in here, I can inspect that, is actually not what I'm expecting. So I'm wondering if I did not set this correctly. I set that to 1 millimeter. But what I can do, of course, I can go to modify sheet metal rules, and this is the rule that we defined, and I'm going to just simply edit this and go to bend condition and get that 1.125 millimeters, for example. Save. And if I now measure that bend radius here, that's 1.125. So if you would have used a K factor different than 0, that number would be different. It would be dependent on the material properties or on the K factor. So the K factor is material property dependent. It's different for steel than it is for aluminum or for plastic here for the flexible PCB. We don't really know what the bend radius is, the K factor, and we want that bend radius here to be the same that we defined in the sheet metal rule. So now we have this we have this Flex PCB bend. What we need to do now to get our geometry that previously was part of this Flex PCB on it, we need to unfold it. So we unfold it, we pick the stationary side, okay, and we unhide all this stuff, and we're going to go to the solid workspace and use the combine command to recombine all this stuff. So the target, and that's important, is the sheet metal. And it's important because we want that sheet metal body to remain a sheet metal body and not a regular solid body. So now we can go here into that group and select all those. Those are going to be all the tool bodies. Shift select all those, and we want to join that. That's correct. Keep all the defaults, and there all our bodies are recombined. And now we go back into the sheet metal environment and say Refold Faces. And there we go. So now what you can do, if you don't want that bend line where it is right now, you could actually go ahead and just drag it where you need it. And that takes a little while because Fusion has to do all that again and go through the timeline and reevaluate. But it does it without a problem. So now if you would want to, you could actually dimension that here. So it's fully constrained. And you could actually also recombine it with that body if you need to, but I don't think there's any need to. So this is one workflow how you can bend existing geometry with Fusion 360. I hope this helps.